Uh, diagram shows the function here, okay? In the domain, stop it, minus 2 to 10. Write down the approximation for the coordinates of the local minimum and the local minimum. So local minimum, guys, okay, what I want you to do here is we're counting how many little mini squares are there. There's 5 mini squares. So these 5 mini squares means that 1 square is worth 1. I do is I go across and I realise that this here has got to be 25. The minimum value of f of x is minus 25. When it talks about the local minimum, it doesn't ask for the coordinates. So the coordinates are going to be 4 and minus 25. Okay, so 4 and minus 25. Okay, so that's the answer to the first question. Very easy. Second question, find the first derivative. What is the first derivative? F dash x equals 2x minus 8. Sketch this into your graph. Remember fx equals 2x minus 8. How do we draw that? Really easily. Go to your table function. Do your 2x minus 8. 2x minus 8. Now look at your, see here, it gives you a domain, doesn't it? Minus 2 all the way to 10. Now, what type of diagram will this one be? How did you know that was going to be a straight line, Sam? If there's no x squared, just an x is a straight line. Another way of telling it's a straight line is look at the y values. They always go up by the same amount. They're going up by 2 every time. Does everybody see that? If they go up by 2 every time, it's a slope of 2. If they go up by 3 every time, it's a slope of 3. So I only really need the first and last point. So minus 2, 12 is going to be, minus 2, 12 is going to be here. Is it minus 2, 12 or minus 2, minus 12? Minus 2, minus 12. Okay, and what's the last point? And we know the last point is going to be 10, 12. Which is 10, 12 is there. Then you link them together using a line. And then this line goes this way here. Now, the graphs actually do touch twice, but they only touch once according to our graph. But what will happen is this blue line will keep rising forever. So eventually they'll hit a second time. Sean, 1 second. Comment on the link below. Well, what happens is, oh yeah. Just to change this slightly. Do you remember that does anybody remember, that your turning point occurs at 4 minus 12, 4 minus 25, right? And remember what we said, you use the first derivative and you put it equal to 0. So 2x minus 8 equals 0. Then bring over the 8, 2x equals 8, x equals 4. This is the value where your line hits the x-axis. That will always happen because your first derivative equals 0 is where x equals 4. That will always happen. Now let me show you another example that's already done for you. Is number 25, okay? Now number 25 you have a cubic function. Everybody see the cubic function? A cubic function, is the cubic function the blue, the green or the red drawn? Is the cubic function the blue, the red or the green drawn? Blue. Cubic function has 2 turning points, a maximum and a minimum. Now look what happens here. We're going to do the first derivative, okay? First of all, which graph A, B or C corresponds to the following? B is the original, the cubic equation. Okay, now we're going to differentiate once. What happens when we differentiate once?
You get 3x squared.
Yeah.
6x minus 9.
Minus 9. What type of function is that if I was to draw it? U-shaped graph. And the U-shaped graph is A, so the first derivative is graph A. And what happens when we differentiate this?
You get 6x
plus 6. What shape is a graph 6x plus 6?
Straight line.
So that implies that the green line, which is C, is the second derivative. Yes?
So, no squared or cubed.
Guys, remember what we said about the turning points. The turning points occur at x equals minus 3. Do you see that point there? Minus 3, and let's call it 34, or sorry, minus 3 plus 33. The minimum value occurs at, what is it? It's going to be 1 and, I don't know, 1, 1. Now guys, the bottom line is the maximum point occurs when x equals minus 3, and the minimum point occurs when x equals 1. Remember what we used to do? Do y dx equals 0. Put that equal to 0 and solve it. I can tell you right away what we're going to get. It's where the red line hits the x-axis at minus 3 and minus 1. Where the first derivative crosses the x-axis will always be directly underneath or directly above the turning points. Remember your last question, for instance. In your last question that we have here, where it hits the x-axis is always directly below or above the turning point in question. Okay? You guys are to do